And so here's your review for the unit exam 0. This is the first problem. You have to simplify the expression. So we're going to use order of operation, or PEMDAS. I see that my parentheses will go first, and the absolute value, it has the same priority as the parentheses. So as I go here, I notice that within this parentheses, there's also an implied parentheses at the top. So I'm going to clear that first. So 4 plus 2 would be 6. I still have it to the third power. That negative is still there, and I know that the square root of 64 is 8, because 8 times 8 is 64. Remember, that negative is there, so I'm not moving it. I copy everything else the same. And negative 3 minus 4, because they're both negatives, I add and keep the sign, so that would be negative 7, absolute value of negative 7. Okay, I'm still not done with the parentheses. I know that 6 divided by 2 over here would be 3, so I have 3 to the third minus, I leave everything else the same. And the absolute value of negative 7 is 7. Remember, absolute value is the distance from 0, so it always will yield a positive answer. So after I'm done with that, I have powers, subtraction, division, and multiplication. So I know that powers are next. So that means 3 times 3 times 3, which would give me 27. And over here, I would copy everything else the same. Okay, so after that, I know that I need to do division and multiplication next before I do a subtraction. So I do left to right on division and multiplication. So negative 8 divided by 4 would be negative 2 times 7. I bring down the 27, nothing happened to it. And there's that minus that was still there, and then the minus from that. So I'll put this in parentheses. Okay, so I still have to do the multiplication. So I have 27 minus, and this would give me negative 14. Okay, remember that every time that you have a negative and another negative next to each other, that becomes a plus. So this becomes 27 plus 14, which gives me 41. Okay, so that would be the answer to number 1. Okay, so for number 2, they're asking me to put these two square roots, square root of 50 and square root of 32, estimate their value on this number line. Okay, so there are two things you can do. Remember that to get the square root, it's easy when they're perfect squares. Perfect squares are like 2 times 2, 4, 3 times 3, 9, etc. All of these would be perfect squares. 50 and 32 are not perfect squares because I cannot multiply a number by itself and give me 50 or 32. So over here you can also change the numbers to square roots of perfect squares. In other words, here would be square root of 9 because 3 times 3 is 9 and the square root of 9 is 3. This would be 16 because the square root of 16 is 4, etc. So you can also change these on the bottom to those perfect squares, and then it's easier to know. Like square root of 50 would be between 7 and 8 because 50 is between 49 and 64, and the square root of 32 would be between 25 and 36, or between 5 and 6, because 32 would land somewhere in between these two perfect squares of 25 and 36. So this would be 32, and this would be square root of 50. And those are the values. So estimating the value, this would approximately be between 7 and 8, and this one between 5 and 6. All right, so moving on. Number 3 asks you to add the following expressions, and I gave you a hint. You're combining like terms, so you can put them all together. So this is the first expression, and you're adding it to this other expression. Okay, so now you would combine like terms. So I see x's. Remember to enclose the sign before it so that you can combine the like terms with the sign that they belong. So the x's, I have 3 minus 5 minus 8. So 3 minus 5 would give me negative 2, and negative 2 minus 8 would give me negative 10. So I'll write negative 10x. For the y's, remember to enclose the sign in front of it. I have 7 and negative 2. So 7 minus 2 would give me 5. So negative 5y. And then finally, the constants, or the numbers that don't have variables, would be the negative 4 and the positive 2. So negative 4 and 12, and positive 12, they're different signs, so you subtract. So that would give me 8. And then you keep the sign of the largest, which is 12, so plus 8. And that will give your simplified expression when you add these two together. For number 4, you need to simplify again. So we don't know the value, but we are simplifying. So over here I see a multiplication, so I'll do the multiplication first and then I subtract. Because I don't know what b is, I cannot do parentheses first and multiply. So that means that I have to use a distributive property here to simplify. I'm going to use the box or tabular method. This negative 2 goes on the outside. Over here I have 5b, and I have negative 3 over here. So then I multiply. Negative 2 times 5 is negative 10b, and I circle that answer. Negative 2 times negative 3 is positive 6, and I circle that answer. Okay, now I will copy what it was circled. So I have negative 10b plus 6. So I took care of all of this already. And then I have that minus 11 to take care of as well. Now I can combine like terms. And these constants are like terms. And the 10b does not have a like term, so it stays. So then that would equal to negative 10b, and positive 6 and negative 11, different signs you subtract and keep the sign of the largest. So there you have it on that one. For number 5, it says, write the equivalent expression to represent the area of Pat's room. So to get the area, I need to multiply this side by this side. So you could do 5.5, which is this side, times the length of this, which is x plus 10. So that's one way of representing the area of Pat's room. Another is to actually multiply each section to know what the area of this is, and then add the area of that. So then you would have 5.5x is the area of that, and over here you would have 55, because 5.5 times 10 is 55, to be the area of that. So the other way would be this. And as you can tell, these two are equivalent expressions. So you could represent the area of Pat's room this way or this way. All right, so turning the page over to problem number 6. Find the missing measurement for Kenny's room. So Kenny's room, this is the area inside this area. Okay, the first section of Kenny's room is 4x. So something times x gave me 4x. So that something must be 4, because 4 times x would give me 4x. And let's test it out. Does 4 times 7 give me 28? Yes, it does. So the missing measurement for Kenny's would be 4 units, which is right here. This measures 4. All right. The next one is a find the error and explain the answer. Okay, so we have to be specific with our explanation. So let's do our work first. So this is the original problem here. So 4 minus 10 times 5 minus 3 times 2. So if I have this, my first step would be parentheses. So the parentheses right here. So I would do 4 minus 10, and then that would give me 2, and then times 2. Which looks like George did that right here on the second one as well. My next step would be to multiply and you go from left to right. So I have 4 minus 10 times 2 is 20, and then times 2. So that's where I think George made a mistake in this step right here. Okay, and then I will continue multiplying. So 4 minus 20 times 2, which will give me 40. Now I can subtract. So 4 minus 40 would give me negative 36. So this is my correct work. So now that I compare, I see that George right here, instead of multiplying this part first, subtracted 4 minus 10 and got 6. So even if that was a step, he should have gotten negative 6, not 6. But that's what he did, and then he multiplied. So when I write the explanation, this is what I would say. So I would say that George did the first step correctly. Did the first step, which is 5 minus 3, correctly. However, the next step was to multiply. And he subtracted instead. You could say multiplication has to be done before division, or has to be done before subtraction. Okay, so George should have multiplied 10 times 2 to get 20, then multiply 20 times 2 to get 40, and finally subtract 4 minus 40. Okay, so I did my correct work, check. I explained why George, or how he made the mistake. Okay, he was supposed to multiply, but he subtracted instead. So here actually I forgot to mention, the next step was to multiply, and he subtracted instead 4 minus 10 to get 6. Okay, so I kind of forgot to mention that. Okay, to be specific. And then over here I mentioned what the correct work should have been in detail. Okay, so when you have an error analysis problem, make sure that you do your own work, that you identify, and here I didn't do it so well the first time, but you identify the mistake. Second step, George subtracted 4 minus 10 and got 6, okay, instead of multiplying first, and then that's the mistake. And then I explained George should have multiplied 10 by 2, and then 20 times 2, and at the end subtract 4 minus 40 to get the correct answer. Okay? So that was the explanation to number 7. The last part, okay, we are solving some equations. First a one-step equation, and then 2 steps. So over here you can do it in tape, or you can do it in algebraically. So I'll do it algebraically first, and then in tape. So if I have x divided by 4 equals 7, okay, in order to isolate the variable x, I need to do inverse operation. So at the end I want x equals on its own. So here x is being divided by 4, so the inverse of divide by 4 would be to multiply times 4. And what I do to one side, I will do to the other. Make sure that step is clear. Okay, so then I'm left with x, and 7 times 4 is 28. If you do it in tape diagram, it already tells me that one tape is 7, and the other tape of equal measure is x divided by 4. So I know what 1/4 of x is equal. It's equal to 7, but if I want to know the whole x, okay, I must have 4 of those, because 4/4 gives me a whole. If I have 4 of those, I have a complete x. And each of those 1/4 of an x is equal to 7. So I have 4 of them, so x equals 28. Okay, so the next one, I draw the line down the equal sign, and I need to isolate the n. Okay, so my first step is to get rid of, remember, the lowest priority. So on this side, I need to get rid of 1/3 and plus 4. So the lowest priority is easy, or the first thing you, which is a plus 4. So the inverse of plus 4 would be minus 4. And what I do to one side, I do to the other. This is 0, so it eliminates, and then I have 1/3 n. These two are both negative, so I add and keep the sign. So I would have negative 30. 1/3 n is the same thing as n divided by 3. So whenever we have a 1 in the numerator, it's the same thing as if you were dividing by that denominator. Here we do the reciprocal to eliminate a fraction, which is the same thing as multiplying by 3. If you multiply by 3, this becomes a 1, and you're left with n on its own. So again, 1/3, just on a side note, 1/3 n is the same thing as n over 3. If you see it this way, you wouldn't even doubt that you know that you should multiply by 3 to want it out. Same thing here, you multiply by 3 to want it out. Okay, so going back to the problem, what I do to one side, I do to the other. So then n would equal negative 90. If you do that on tape, okay, you have one tape that equals 26. The other tape equals 1/3 n plus 4. So you know that this is plus 4. So the 1/3 n piece, okay, the 1/3 n is this part, and that must equal negative 30 in order for negative 30 plus 4 to equal the negative 26. So this piece has to be negative 30, so that together they equal the negative 26. That negative 30 again is equal to that 1/3 n, but I don't want to know 1/3 of an n. I already know that's negative 30, but I don't want to know the value of 1/3 n. I want to know the value of a whole n. So if I have 3/3, that would give me a whole n, and each of those is worth negative 30. So that means that n must equal negative 90. So that's a take for letter B. And finally, the last one, algebraic, I put the line down the middle. I must isolate the w. Okay, and the 5 and the w are being multiplied, so the opposite or inverse of multiplication is division. So instead of multiply by 5, we'll divide by 5, and this becomes a 1. I have w, and what I do to one side, I do to the other. Okay, so 21 divided by 5. Here you don't have to do anything to it. You can leave it as an improper fraction. You can convert it to a mixed number, or you can convert it to a decimal. Okay, but just keep in mind that this is an acceptable answer. You can leave it as 21 over 5 because it's reduced all the way. These, you don't have to do them unless they ask you to in the problem. Again, this is a perfectly acceptable answer because it is reduced all the way. Okay, so if you were to do it in tape, okay, you know that 5 W's is 21, so here's 21. And if you had 5 of those, okay, each would be 21 divided by 5 because you want 1/5 of that. So W equals 21/5. Okay, so that concludes your review. So make sure that you go back to all your notes and also study your notes. You will have questions like all of them that are here. So please study and good luck tomorrow.